Hello friends, today we are going to see renewable energy engineering, in which we will discuss about vertical axis wind turbine. What are its advantages, disadvantages, components, and different types of applications of this vertical axis wind turbine. So VAWT stands for vertical axis wind turbine, which is a type of turbine where the main rotor shaft is set vertically and the main components are located near the base of the turbine. Now in case of horizontal turbines, which have their rotor shaft and blades which are oriented horizontally, in vertical axis wind turbine, it is like rotor shaft is set vertically. So VAWTs have their rotor shaft oriented vertically. So in the figure you can see the difference between these two. The first picture shows the horizontal axis wind turbine and the second here the vertical axis wind turbine. So here you can surely see the difference in the diagram, how the rotor blade and rotor axis is located. Here is the vertical and here it is the horizontal, and the purpose of this both are to produce electricity. So in this clear picture you can see how this vertical axis wind turbine works. So this is the vertical axis wind turbine, and here you can see the rotor blades, and these are the gear wires and the generator. This is the hub and the gearbox, and this gearbox is connected to the generator, and whenever the wind comes and passes across this rotor blade, that wind which is having the kinetic energy, then it is converted into the mechanical energy by the gearbox, and then this mechanical energy is converted into electrical energy with the help of the generator. So the components of the vertical axis wind turbine consists of the rotor. The rotor of this is vertically, as we have discussed earlier, and the blades can be curved or straight depending upon the turbine design. The shaft, that is the main shaft of the vertical axis wind turbine, is vertical and is connected to the rotor. So the rotational energy of the blade is transmitted to the shaft. Now at the base of the turbine there is a generator, or you can use other power conversion system that converts the mechanical energy from a rotating shaft into electrical energy. And last one is the support structure. So these vertical axis wind turbines are typically mounted on a fixed or adjustable support structure that keeps the turbine stable and allows it to face into the wind. So these are the components which vertical axis wind turbine consists of or comprises of. So the working principle, as we have discussed in detail, we can see here. First of all is the wind capture. As wind blows against the turbine blades, the rotor rotates around the vertical axis. So the blades are designed to capture this wind energy effectively from any direction, making this turbine suitable for changing wind conditions and turbulent airflow. Then comes the energy conversion. So the rotational motion of the rotor shaft drives the generator located at the base of the turbine. The generator converts this mechanical energy into electrical energy, which can be used to power electrical loads or to be fed into the electrical grid. So what are the advantages of this? This first is omnidirectional. That means vertical axis wind turbines can capture wind from any direction, including turbulent or changing wind patterns, making them suitable for urban or complex terrain environments where wind direction varies. Second one is the lower height. So vertical axis wind turbine typically have the lower overall height as compared to the horizontal axis wind turbines, making them more suitable for the areas with the height restrictions or where aesthetics are concerned. Then the maintenance. In case of the maintenance, many components of vertical axis wind turbines such as the generator and gearbox are located at or near the ground layer, simplifying the maintenance and the repair tasks, which will be difficult in case of or complex in case of horizontal axis wind turbines. Then it produces less noise. Vertical axis wind turbine often produce less noise compared to horizontal axis wind turbines because generator and gearbox are located away from the rotor, reducing the mechanical noise transmission. Also, it has got certain disadvantages or limitations, you can say. The efficiency, first of all. Vertical axis wind turbines generally have lower efficiency compared to the horizontal axis wind turbines, particularly at larger scale due to the blade design challenges and aerodynamic limitations. Then the design is complex, that is complexity of design. So designing efficient vertical axis wind turbine can be challenging due to the blade and the rotor dynamics, resulting in higher development costs and longer design cycles. Then third one is the scale limitations. Vertical axis wind turbines are typically used for smaller scale applications such as you can use for the residential or distributed energy systems and may not be suitable for the utility scale power generation. Then comes the next point, wind power availability. So the wind power availability depends upon the following factors, that is the wind speed. The primary factor affecting wind power availability is the wind speed. Whenever there is a higher wind speed, generally results in the greater power generation. So wind speed is typically measured at different heights above the ground level as wind speed increases with altitude due to reduced surface friction. Second one is the wind turbine efficiency. Wind turbines have a cut-in speed, that is the maximum wind speed required to start the generating electricity, and cut-off speed or cut-out speed, the maximum wind speed beyond which the turbine shuts down to prevent damage. The efficiency of converting wind energy into electricity varies with the wind speed. Third comes geographical location. The location of the wind farm or the turbine greatly affects the wind power availability. As you see, coastal and mountainous areas tend to have higher and more consistent wind speeds, making them ideal location for wind farms. Seasonal and diurnal variations. So the wind patterns can vary seasonally, as all of us know, and throughout the day. For example, coastal areas often experiences stronger winds during the day due to temperature difference between land and sea. Climate patterns. Larger climate pattern systems such as monsoon or seasonal wind patterns can influence the wind availability over longer time frames. So local terrain obstacles. Local terrain such as the hills, forests and buildings can affect the wind flow and lead to turbulence which may impact wind power availability. And last one is the wind turbine setting. Proper setting of the wind turbines involves considering all of the above factors to maximize wind power availability and efficiency. So this wind power availability depends upon these factors as we had discussed. Then we can go for the evaluation of sites for bioconversion and biomass. So this can be done when you have certain following availabilities such as biomass availability, assesses the availability and sustainability of biomass feedstock in the region. Then the feedstock characteristics, and understand the physical and chemical properties of the biomass feedstock such as what is the moisture content, what is the lignin content, what is the ash content, as these impact the bioconversion process. Then it comes transportation infrastructure. Evaluate the transportation logistics for delivering biomass to the bioconversion site. Then next point is the water availability. So there must be access to sufficient water for the bioconversion process, especially for fermentation or other aqueous based conversion methods. And last one is the energy supply. Consider the availability of energy sources required for bioconversion process. Renewable energy sources like solar or wind can enhance sustainability. Then comes the waste disposal management. Plan for the waste disposal and management of the byproduct generated during bioconversions such as ash or digested from anaerobic digestion. Environmental impact. Assesses the environmental impact of biomass production and bioconversion activities including land use change, water consumption and greenhouse gas emissions. Then comes what is the market and economic factors and site specific. So all these factors will be there for evaluation of sites for bioconversion and biomass. Then we can also have the infrastructure needs, community and stakeholder engagements. Then comes, we will discuss about the biomass gasification. So what is the process is all about? First of all, you have to have feedstock preparation. Agricultural waste is collected, sorted and sometimes dried due to reduced moisture content. Then this gasification process involves the biomass is converted into syngas through partial combustion at high temperature, typically around 700 to 1500 degrees Celsius, with controlled oxygen supply, or you can say limited air or oxygen. Syngas cleaning. The raw syngas undergoes cleaning process to remove impurities such as tar, particulates and sulfur compounds. Syngas utilization. So the cleaned syngas can be used directly in the engine or turbine for power generation or further processed in biofuels such as methanol, ethanol or chemicals, example hydrogen. So friends, today we have discussed about this renewable energy engineering part, of which we can have a vertical axis wind turbine, then the evaluation sites for the biomass, and we have discussed between comparison between vertical axis wind turbine and horizontal axis wind turbine, and what is the biomass gasification. So in the coming lectures we will discuss further different types of renewable energy sources. Till then, thank you very much.